Hello everyone, and welcome to our second video about static methods for AP Computer Science. We're going to continue where we left off last time, and last time we discussed creating methods of our own, and we discussed a few concepts. One, how we define a method, and two, how we can access or use it in a context that's not tied to a particular object. And we talked about the keyword static. We used another keyword public. We also used the keyword return. Those were three big keywords that we talked about. Public was what we called an access modifier, and it says who is allowed to use this, and so far this is the only one we've seen. And so as we make our methods right now, anyone can use them, and we'll see a brief example at the very end of this video of how we can use it in another class. We kind of already saw it last time, but we'll be more explicit about that. We mentioned the static keyword basically says this method is not going to be called by any particular set of data or object, like a string would or a scanner might call methods. It's going to be much closer to the concept of math functions or math methods that are just kind of tied to a class or grouping, but basically they're on their own and they're independent, and their only context is their data or their input, but they are not connected to a particular object. And then we saw the return keyword, and that was basically because we make a contract by writing our signature with a return type, we're saying, well, I promise to give back data of this kind. And the return keyword says, well, okay, I'm giving back the data, and it validates that it is matching in the type. So in our example, we had done a comparison, it was Boolean, and that variable content was returned, and it was also Boolean, which is what our signature asked for. So this time, let's make another example. Let's go back to what we did before when we were learning our math. How about we take the code that we wrote for finding the quadratic equations answers given an A, B, and C, and put this into a method. And this would be very helpful because what happened is our code said, okay, you give us an A, B, and C, we calculate the quadratic equation, the two answers, and then we made a nice little string representation. We're going to do the same thing. So we know our data type return is going to be giving back a nice little string. Our inputs will be numbers, and we'll make them doubles because we had said that it's possible to have A, B, and C as decimal numbers. And then we'll do the implementation pretty much how we did it the first time around. So again, the same thing we're going to do every time. We always ask ourselves the same questions. Right? Who's allowed to use our method? And again, for now, our answer is everybody. So let's go ahead and before we start, let's go ahead and give our goal. I should have put this over. Let me move this real quick just so we have this part. Here we go. So we know what our goal is, and we'll do the same thing. We'll do the same thing here. So we'll say method goal, return a string representation of the solutions to the quadratic equation given an A, B, and C value. Or given, not and, but given A, B, and C values. Okay? So let's go ahead and make our signature. Again, who is allowed to use it? Our access modifier. For now, it's everybody, so our keyword is public. We're going to use static because, again, in this the context is purely just the method. It's going to be kind of loose. It's in this class, so we should be putting the word static. And our return type. I said a string representation, so string is a data type. Let's return a string. And then now our name. So this time I'm going to try to go up with a shorter name, and I'm just going to call it quadratic. And now our inputs. Remember, we always need parentheses even if there are no inputs. In this case, there are actually going to be several inputs. And we said last time that they are comma separated, and each input is represented by a data type and a variable name. So here we go. We're going to say int A, int B, int, oh, sorry, not ints. Maybe a better choice would be double. We talked about decimal numbers, so double A, double B, and double C. So here's one of the few times that you might hear me say it's okay to make a single variable name because A, B, and C are literally what they would be called in the quadratic equation, right? And now our body, which is always represented by curly braces. And again, that same error pops up and says, hey, you promised me you were going to return a string, you haven't done it yet. Well, the IDE is being a little aggressive with us, and we have to kind of implement it and fill it in. So if you don't remember the quadratic equation, we know it is minus b plus or minus the square root of b squared minus 4ac over 2a. So I'm going to do this a little bit quicker than last time. Instead of making many, many variables, we're just going to make a couple. So let's say double add top is going to be minus b. So this is going to be the part, this is going to be the minus b plus the square root over 2a. Or sorry, not over 2a, but just this plus the square root. Actually, let's just do it all in one line. Let's be quick about it. We'll say add answer is minus b plus the math dot square root. Oh, my computer is kind of stalling for a moment. I heard it by typing it. No, I didn't want you to use that. I don't know what that is. Square root. And the input to the square root we said was b squared minus 4ac. b squared, I could use math.pow, but we mentioned early on where if the power is basically 2 or 3, you could probably just do the multiplication. So let's just do b times b, which is b squared, minus 4 times a times c. And I don't have to put parentheses around the b squared or the 4ac because multiplication happens before the subtraction. Multiplication happens before the subtraction, right, each one, and then the subtraction happens. So that's already the correct order. And then we said all of this divided by 2a. So we should do parentheses around the entire top, and then divided by parentheses around the bottom, which is 2 times a. Right, the division should happen last. And there's all of our thing that we did in multiple variables last time in one long formula. And now we can just do the exact same thing, double sub answer, and we'll say is equal to minus b minus math square root of b times b minus 4 times a times c divided by 2 times a. And there are two answers. And then we had said last time we had two different ways of doing it. We can print all the individual things, or we could concatenate all the things together into one answer. And here we're not going to print, because printing displays stuff to the console. It doesn't give back information. And so since we have a string return type, we need to create a string so we can build it by concatenating different things together. And so let's go ahead and do that. And then we'll return it at the very end, because we do need a return statement. So let's go ahead and say string answer is equal to, and I had showed us last time that the format I wanted was a curly brace, a number, comma, the second number, and then a curly brace. So we'll put a literal curly brace, we'll put a space, we'll concatenate the first answer, which is usually the addition one, so we'll say add answer, and then we'll concatenate a literal comma space, because that's the separation, and then we'll attach to that the subtraction answer, so sub answer, and then we'll attach the space in the close curly brace. And there it is in one line, so this is a pretty short thing. And now again, notice if I had multiple numbers, I would have to constantly write these lines and reassign them and put them in main and so on. So now I'll be able to just say quadratic of 3 numbers, and the result will be a string that is the answer. So now let's go ahead and return our thing. So again, if you have a return type that is a valid data type, you must have a return statement that returns something that matches it. And it could be anything. It could not be the correct answer, but it has to be the correct type. So I'm going to say return. And in this case, the only variable in my code in this method that matches string is answer. So we're going to return whatever is inside of answer. And there it is. And notice the error is gone, and our method is available now to use. So let's go to our main. And again, I'll just kind of see that this is not too big, but still, the more implementation you have, the better off you are, because that way now we can just call quadratic in our main, and it's a lot easier to manage. So let's try that. So here we go. Let's say something like string q answer is equal to, and again, the way we're going to call static methods, the proper way, the official way, is the name of the class that the method is in, and then the name of the method. It's still dot notation, but it's not an object calling it, it is a class. So creating methods, which is the class we're in, dot, and now notice even NetBeans recognizes it as part of it and even tells us, oh look, there's the return type, and so on. So we're going to call this quadratic. And then now we're going to plug in numbers. And I can't remember what we said. I think it was 1, 2, 1, A for 1, B 2, and C 1. And that gives us 0, 0, or -1, -1. So let's try it. And now it has to be doubles. Could I make double variables? Sure. Could I put literal doubles? Sure. Could I put ints? Yes, because integers can be converted to doubles and therefore will work nicely with the variable, just like we had done before. So I'm going to go ahead and put them as doubles, literal doubles. So 1.0, 2.0, and 1. And I'll just put the integer just to prove that it does in fact work. And there it is. So it says, okay, I recognize it. You're giving me 3 inputs that can be equated to doubles. It's going to generate some answer. It's going to store it, and then we can print it out. So we can say system.out, quadratic answer. Let's attach whatever Q answer was. And let's see. And there it is, and I was correct. It was -1, -1. And so notice that if we look at this line, it looks like it's one line, but again, just like with the math library, what we're doing is we're hiding implementation details somewhere else. Again, since we were the designer and we wore the hat of the designer, we know what the details are, but theoretically, if someone else was using our functionality, they might not know, and that's okay. They just need to know, well, what is the input, what is the output, and what are the rules for following. And this is how we talked about the Java API, because the Java people have written so many classes with so many functions, static and not, and all these different things. They have a giant set of documentation, the API, that tells you how everything works. So if we were good programmers and we were professionals, we would write instructions for the usage of these methods, right? Our thing is right here, and we're maybe not being as clear as we could be, but the idea is that we could give details into what should the inputs be, what ranges should they be in, maybe what problems might occur if you give it bad values, and so on, right? But that's, I think, a pretty reasonable one to do. And so it's not too difficult. And again, we're calling these methods. And I'll mention one more time, because we happen to be in the same class where the method was defined, we strictly speaking are not required to use the name of the class in front of it. So I'll prove it by just throwing it away, and it finds it, right? So it's not a problem. And now what I'm going to do real quick just to prove how this actually works, I'm going to go to one of the other classes that's in our package basics, and I'm going to try to call this quadratic method. So here we go. I'm going to actually go to our arithmetic class, because that's where we first did our quadratic equation, right? We did it right here, and look at all the code that we wrote for it. And let's go ahead and call it again at the very bottom. And we'll see how we can do that. So let's do this real quick. We're going to say string quad, and we're going to say, and so now if I just say quadratic, which we know what it's called, and we said 1.0, 2.0, and 1.0, it doesn't work. It says this method does not exist. Cannot find it in the class arithmetic because it wasn't written in arithmetic. If I save everything, and so the answer is, if you are not in the class where that static method exists, just like we weren't in the math one, you use the name of the class to call it. So if I called creating methods dot quadratic, suddenly there is no problem. And so this is an example of a situation where a static method could be called outside of the class as long as you use the proper format, which is class.method. So right now there are two ways of using dot notation. Object.method, so an object like a string or a scanner or something that exists in RAM, or a class name dot method. The class ones are the static ones that only have the context of their input. And the non-class ones, the object ones, are the ones that have the context of the information of that object, whether it's a scanner or a string or whatever it may be. And so there we can see that we've called a static method. And it's very useful. So now we've minimized all this work and we crammed it into one method, and now we can call it 40 times and we only have 40 lines. We don't end up having these 6 lines 40 times, which is much, much more code. Plus, of course, the prints and all that stuff. Now we can just print out this answer and it's nice and fast. So let's go back to our creating methods class and let's do one more example. And so in this one, what I'm going to do is I'm going to give you the goal, and I'm going to tell you pause the video and maybe try to implement it yourself. And then I'm going to go and implement it, and we can talk about that. And you can see how close you were and if you pulled it off. It's really just a matter of planning and thinking about what you need to do. Ask yourself who's allowed to use it. Ask yourself, should it be static or not? Ask yourself, what is the return type of the information I'm giving? Pick a name. Ask yourself, what is the input? Should there be input? Do your implementation, return the answer, and then test it. So let's do this. This last one, method goal. Given a first and last name separated by a space. Well, actually, let's be a little more specific. So I'll be nice and try to give you as much detail as possible. Given a string containing a first and last name separated by a space, return a new string that has reversed the name into the format last name, comma, first name. So for example, if the input was a string that has Joseph space Rivera, the answer that's returned should be Rivera, comma, Joseph. If the name was Jimbo space Jones, the answer should be Jones, comma, Jimbo. And so we'll focus only on two names, first name and last name, even though realistically many people have multiple last names or hyphenated names or things like that. But we'll test on one word at a time, and then we'll see maybe our implementation is good enough to handle multiple last names. It's all about how you implement it, so we'll see that. So I'm going to stop here and say, give yourself a little bit of time, pause the video, and try to implement it. And then come back to the video and let's see. Okay, so I'm going to implement it, and so hopefully you pause the video, and let's try doing this. So I'm always going to follow the same strategy, and it may seem kind of silly, but it's what really helps cement the ideas of what you need to do in our minds. So first question, who's allowed to use our method? Right now we only have one answer, everybody. So public access modifier. Should it be static or not? Yes, because there is no context except the input to the method, which is whatever the string is going to be, so we should make it static. Our return type. If I was given a string and it says return a new string, our return type should be string. And then our name, so I'm going to call it reverse name. And this is the part that's the least important. You should follow the standards. You're not required to, but it's a good idea. And just be descriptive. It's not that important. Our inputs. Should there be inputs? And the answer is yes. We're given a single string that contains both words. So we'll say string full name. And there's our input. And now I'm going to put my body. So how do we implement this? Well, we know that this is one string with a space, at least one space somewhere in it. And the assumption that we make is if we find a space, that's the separation between the first name and last name. So what I'll say is, why don't we use some string methods to find the space, use it as a marking point, and then substring or take a piece of the original full name from the beginning to the space and from the space to the end. And the idea is what will happen is we'll get both parts, the first name and the last name. And then we can combine them in any way we like. So let's go ahead and do that. Let's say it's going to be an int because we want to know the index of the first space, right? Where is it in the string? And remember, every character in a string has an index starting at 0 from the first character. So space, IDX. And we're going to say, and if you don't remember the method that lets you search for content and be given back an index is index of. And now again, notice this is not a static method. This is a context sensitive. Whose string or whose data are we looking through? In this case, it is a specific string, full name. So we're going to say full name dot index of. And then it tells us to put a string to look for. I'm looking for a space. So there it is, a literal space. It says, can you find the first space starting from the left of the string and tell me the index that you found it? So if it was Jimbo Jones, then J is 0, I is 1, M is 2, B is 3, O is 4, space is 5. So it would give us back 5. So, and again, depends on the string. It doesn't matter as long as it finds the space. We're not going to make the assumption that it's Jimbo because that would be a set string. Instead, we're saying, you know what? Index of, find wherever the space is. And I'll take that number and do what I need to do with it. So now, let's say string first name. Well, we just said the first name should be every character from the beginning of the string to the space, but not including the space. So full name is the string we're going to cut from. Substring doesn't really cut, it just takes copies and makes a new string. So substring is the method that's going to help us do that. And since we're starting at the beginning, substring says if you give me two numbers, the first number is the starting index, inclusive. The last index is not, the ending one, the second number is not inclusive. So I'm going to say, let's go from the beginning, which is always 0, to the index of the space. So space IDX. And the reason I only leave it at space IDX is because it's not going to include it, which is perfect, because I don't want the space as part of the name. It's not Jimbo space, it's just Jimbo. And so that's fantastic, so it's not going to be inclusive by default. And so there's our first name, Jimbo or Joseph or Bob or Helen or whatever it might be. It doesn't matter what the name is because it's up to a space. And now let's do our last name, string last name. So now you can imagine we know where the space is, and we know everything before the space is the first name, and therefore we could argue everything after the space is the last name. So we can use substring again. We can say full name dot substring. And now where do we want to start? Do I want to include the space or not? The answer is no. And so therefore, if I start at space index, then I would include it. So how about we start one off from it? So one more past it. So if space index is 3, we would start at 4. If space index is n, we start at n plus 1. So we'll say space idx plus 1. And then again, we're going to say, well, the assumption is that after the space, whatever's after it is the last name, no matter how big it is. And so do we have to put a second input to substring? The answer is no, because remember, the first version of substring, I forgot the N, the capital N in full name. The first version of substring, if you give it one number, says start here and go to the very, very end, which is exactly what we want. So if we did this correctly, we have a first name and a last name. And now we can combine them again, but in a reverse order. So let's do that. Let's go ahead and say string reverse is equal to, and what we said was it would be the last name, whatever it happens to be, concatenated with a comma and a space, right? That was the example we have here. And then attached to that would be the first name. So that theoretically is the reversed name. And then because it is a method and because we promised to return a string, we must have a return statement. And reverse happens to be the answer. Now, theoretically, we could return first name, we could return last name, we could return reverse. The one that's the actual answer is reverse, so we should probably return whatever is inside of reverse. So return is our keyword, and the content we want to send back is the content of the reverse variable. So let's finish this up by testing it and validating it. So here we go. Back in our main, let's say string full is equal to, and we'll start off with my name, Joseph Rivera. Okay, and let's try doing our method call. So we'll say string rev for the reverse, and I'm going to point out something, and this is some more details. I'm intentionally giving different variable names, but could I use the word reverse? We've hopefully seen before, if you're in main, once you declare a variable, you're not allowed to redeclare it. You can use it again, reassign it the same value, but you can't make a second variable with the same name. But now that starts to be kind of maybe not so true anymore. And I'll go ahead and prove it by actually calling this reverse, and we'll talk afterwards about why this is the case. So string reverse. And now I can call the method. I'm going to call it the proper way, creating methods dot reverse name, and my input is full, and the output should be whatever the reverse happens to be. And actually what I should do is I'm going to put a note here real quick because I realized I never wrote it. If the method is in the same class, well, actually, let's say if the method call is in the same class as the definition, the method no class name is required, right? So that's why quadratic was called here. And so again, I could have just said reverse name, but I'm going to do it the formal way just to be consistent. And now we can go ahead and print out. Let's go ahead and do something like original, and this is going to be full, and let's do our reverse. Reverse is reverse. So here we go. I'm going to right click and I'm going to run. Hey, looks like it's correct. Joseph space Rivera, and I end up with Rivera, comma, space Joseph. Now let's test it again just to make sure that it's not just a coincidence. We'll do the example of Jimbo Jones. I'll run it again. Jones, comma, Jimbo. This looks good. How about Timothy Lee Rodriguez? Now this is we'll say that the first person's first name is Timothy, his last name is Lee, and then he has a second last name, Rodriguez. So Timothy Lee Rodriguez. So now how is this going to show up? I argue if it's correct, it should be Lee Rodriguez, comma, Timothy, because both of these are considered the last name and the first name is Timothy. Let's see if that's what happens. And it looks like it's correct. Lee Rodriguez, comma, Timothy. And the argument is because we only looked for the first space, and we said anything before it is the first name. Anything after it is the last name. So it takes both of these as part of the last name, which I think is pretty reasonable. And let's do one last one. Imagine if he had a middle name. So imagine if his full name was Timothy Augustus Lee Rodriguez. So his first name and his middle name are Timothy Augustus, and his last name is Lee Rodriguez. Imagine if this was the case, what would I expect to see? I would argue we should see Lee Rodriguez, comma, Timothy Augustus. Right? So let's see if that's what happens. It didn't work out so great. Now, see, this is where the flaw kind of happens, right? Because we said, well, again, we look for the first space, and we argue anything after the first space is the last name, anything before it is the first name. So this is not flawless, and I would argue that what I wanted is not exactly how I implemented it, and that's kind of a flaw we have to do. And that's not a problem. Now, do we have the tools right now to make this that flexible? I think the answer is not just yet. We'll get to that point, and it would be a great exercise to make it so that it can handle any number of first names and any number of last names. But that might be a genuine challenge. So we'll come back to that maybe in the future. That's definitely... And I'll point out that this is actually, as silly as it might seem, a huge problem with common programs for professionals all the time. Dealing with names, because every culture has a different way of writing names, and some people use first names first, some people use last names first, some people have hyphenated names, some people have what would look like hyphenated names, but they don't put the hyphen, and all those different things can really affect how a program takes in user input. And if we're going to put a name into a file and just assume it's always first and last, that might not always work out. And so this is kind of one of those technical issues that we go, how do we solve this problem? But we're not going to be able to do it right now, so we'll let it go for now. Right, so we'll leave it at this point. I think this is pretty good. So I'll see you in the next video. We'll be talking about more different topics, but we are on our way into a much more exciting form of programming that's going to give us big picture problems to solve, but we're slowly getting to that point.